So the first mistakes I made was fake features. I thought that this timer was what we could use because it made sense. I went through systems.time and I saw timer, but it turns out I could have used basics. So the timer wasn't part of the original full syllabus. So the first mistake is fake features. I used this fake feature because I researched it, and as it turns out, it actually didn't solve my problem. Maybe I should have ChatGPT the problem a bit better to get at least a solved solution. Because as it turns out, the examiners were aiming to look at how we could use our knowledge of date and time modules and system, built-in functions to build up a logic that helps us to find the time taken. There was actually a much more common sense answer, which required us to just have the time, the date of the time, the date time of when we started, and then the time when it ended, and then we could subtract that and get the time taken. And that could have been done with built-in functions that the syllabus, the BTEC syllabus, kind of expected us to know. So they wanted us to use that thinking and be like, okay, you could use your everyday time, date time module that is being taught from syllabus to solve that problem, rather than looking for a whole new thing. For me, in my case, didn't solve the problem. So firstly, just take a mind of fake features. Try not to implement too overly beautiful features into your program. Even if you've researched it, it should kind of still be all under, the scope of what they expect you to use as well. I don't know if you might lose marks for using a whole new thing. It might show that you went home and did. I don't know if that's going to be degraded, but I think it'll be much more exam friendly if you used features that that exam board kind of expects you to use. They wouldn't go outside that. They expect you to use what's inside that, and get together your code. So that's one mistake I made and definitely would not be making again. Second mistake is skipping validation. This is something I used to do before. This is a mistake I just want to bring again. Do not skip validation. Do not assume your users are going to get your inputs their inputs correct. For every user input, validate via validation loops. Don't validate once. Validate using a loop. So use a validation loop. Don't just validate with like an if statement. Validate with a loop, not an if statement. So reinforce your skill of loops and using loops to validate. I definitely am going to do that. I've been working on this for quite some while, and I know that this needs a bit of working. And I think this is quite good because the user only gets to know what they're supposed to input, and then they get to write this continually, and they don't have to it doesn't have to be a redundant thing. It's like if they get it the first time, they can pass through the program, rather than if they get it the first time, your loop will have them go through it again, even if they had passed. So that think about that. Think about your user. Your users are not going to get everything correct. Do not assume that. Mistake number 3. Jumping right into code. This is a mistake I used to be quite on. Spots on mistakes I was on. I've learned not to jump into code. Kind of break it down. The BTEC overall, looking at the past papers so far, you can tell that they expect you to do 3 main things: inputs, processes, outputs. That's how it is. They will always say, okay, we expect the user to input these, we expect the following things to happen in between, and then we expect to see a display of something. Split your program into these 3 things and think about how your program is going to be made to solve the input bit, the process, the main process they want, and then the output they need. Break it into that, and from there you're good to go. Another thing would be partially meeting requirements. Another mistake I used to make. I used to think it's better to have everything figured out. It's better to have a partial but full working program than to have a wholesome program. No, it's better to have a wholesome product, a wholesome solution, program solution. If you cannot give, let's say you forget something, you don't necessarily have to waste your time. Also, don't waste your time trying to solve a little problem. Write a comment there and say, I'm supposed to do this process, or I'm supposed to take this input. Maybe you can go home, revise what that looks like, or go home and think about what that process is. Just try not to waste too much time in solving that problem. So do not be a fan of partially met solutions. Try to complete your program, even if it's with comments. And anywhere you think you're faltering, use Studio Code to build your logic up, because they know, they can see that you were thinking that way, and they can hopefully, in the code they see, they will put you up in a higher band because they see that you were able to think logically that way, and probably just had a little problem figuring out what the coding solution looked like. So yeah, it's better to give, and when I mean wholesome solution, I mean wholesome in the sense that the program looks, because I don't think they would run your code. I don't think they'd have time to run everybody's code into some whatever IDE or whatever it is they need to do to check if it runs. They will look at your program, check how the logic is. If the logic is messy in a bit, they'll be like, okay, that logic is bad, or if it's not readable to the user, or if your inputs don't make sense, or your outputs don't make sense, or your variables, or there's no consistency. They look at these things. Your comments too. So try to comment it. Also, don't try to fake it till you make it. Another thing is the evaluation bit. Prioritize quality over quantity. How do you do that? Don't just describe. Try your best to not be a describer. Don't just describe. Tell them what it is, how it works, and then judge it. And then give a justification to why you used it. Why you used it first, and then you judge it. And then if you've got time, tell them what improvements you can make. If your solution or whatever it is has a limitation, judge it. If you think it's good enough, judge it that way, and then you tell them why you think so, and then you give them, probably if you've got time, how to improve. So that's how to work on your evaluation. Don't just go in thinking, what did I do? I'll just tell them all I did. The more you write does not equal the more marks. It's how you write, like what's in your writing. Quality matters. Poor testing. Do not poor test. Test for normal, abnormal, and extreme. Normal, let's say they give you an age. Age must be between 5 to 15. Normal test means that the data passes for, if the user inputs 6, 7, 10. Abnormal, 1, 16, a little bit outside the boundaries, -1, and so forth. Extreme, different case, data type. Let's say the user types in FIVE 5 or SIX 6. That's extreme. Can your code handle that? So those are the things you need to test for. And I think that having that in your code, I think that's where validation comes in to help. So having validation loops in your code is really important. And then the one thing I fall victim of, panicking. What do I do when I'm panicking? Oh, I don't know this. Oh, I don't know what to do. Calm down. Take a breather. And the next thing you have to think about is, how am I recovering from this? Am I writing a comment so that I go home and do and work on what features, I missed when I go home? Think of your recovery strategy. Don't waste time crying over spilt milk. Don't waste time crying over what you couldn't do right. Don't force yourself to memorize. The key thing about this exam is that they're not looking for people who can memorize commands or things like that. They're looking for people who can problem solve. The syllabus it's not too heavy. They just want you to use all these things that you've been taught to solve a problem. You're going to break down things and you're going to solve a problem. Decompose and pattern recognition. Those are the main skills they look for. That's the thing about this exam. I didn't lose marks because I didn't know how to code. I lost marks because I didn't think like the examiner would. If you fix that, you'll be ahead of most people. Main things, read the instructions, guys. If anything, read instructions. Spend time thinking. Don't rush it. Do not rush it. Now this involves a level of thinking, which is good. Break down problems. Think of it in your head and then write it down in pseudocode and then write in code. Or if you think of it in your head and then write it down in code, that's also okay. That's also fine. Now break it down into inputs, processes, outputs. You'll be fine. You'll be fine. Good luck.